Good evening, students. Today I thought to continue the biology lesson from the place where you have stopped. So, Miss has told me that you have discussed the following systems in the human body for the lesson. She has discussed the digestive system, then the respiratory system, excretory system, and the blood circulatory system. So that you know that there are two circulatory systems in our body. Blood circulatory system is the major one, and in addition to the blood circulatory system, there's another circulatory system in the human body, which is called the lymphatic system. So there's a major difference between the blood circulatory system and the lymphatic system. There is no pump, there is no heart for the lymphatic system. It circulates a fluid called the lymph, which is also a product of the blood circulatory system. And so that the blood circulatory system and lymphatic system work together, they work simultaneously and conduct the transportation of materials throughout our body. And the lymphatic system has a major function in the protection of the body organs, especially from the infectious diseases. So before we discuss about the lymphatic system in detail, we will watch a video clip prepared for the lymphatic system. Then after we will continue our discussion as usual.
And lymph nodes, which make up the lymphatic system. The three major roles of the lymphatic system, the reason we need it in the first place, are that it returns fluid from the tissue back to the heart, it helps large molecules like hormones and lipids enter the blood, and it helps with immune surveillance to keep infections from running amok. So let's take a closer look at lymph and where it comes from. The blood in the arteries is under a lot of pressure because it needs to reach every little nook and cranny of the body. Those arteries branch out into narrower and narrower arteries, and then arterioles until finally it gets to the capillaries, which have walls that are only 1 cell thick and are slightly porous. Red blood cells are too big to fit through the capillary pores, but small proteins like albumin and fluid can make it through. Every day, 20 liters of fluid, water, and protein seep out of the capillaries and becomes part of the interstitial fluid between the cells. About 17 liters gets quickly reabsorbed back into the capillaries, but that leaves around 3 liters of fluid behind in the tissues each day. This 3 liters of fluid needs to find a way back into the blood so that the body's interstitial fluid volume and blood volume both stay constant over time. That's where the lymphatic vessels, or just lymphatics, come into play. They collect excess interstitial fluid and return it to the blood. Once the interstitial fluid is in the lymphatic vessels, it's called lymph. You might be wondering how there can be 20 liters of fluid seeping out each day if the blood volume is only 5 liters. Well, remember that the 5 liters is constantly in motion, and then it gets recycled over and over every single day. Unlike the circulatory system, the lymphatic system isn't a closed loop because fluid and proteins make their way into the microscopic lymphatic capillaries, and all of the collected lymph is dumped into the veins. Lymphatic capillaries are the smallest lymphatic vessels, and they're located throughout the interstitial space. Lymphatic capillaries are extremely permeable because their walls are made of endothelial cells that only loosely overlap, forming one-way mini valves. These endothelial cells are anchored to structures in the interstitial space by collagen filaments, which allows the lymphatic capillaries to stay flexible but retain their overall shape. When the pressure in the interstitial space is greater than the pressure in the lymphatic capillary, the endothelial mini valves open up, allowing fluid to get in. When the pressure in the interstitial space is less than the pressure in the lymphatic capillary, the endothelial mini valves are pushed shut, which keeps the lymph inside. Once that lymph is inside the lymphatic capillaries, it travels through bigger and thicker walled vessels, then trunks, and then ducts. There's no pump pushing lymph through the lymphatic system. Instead, smooth muscle in the lymph vessels reacts to the pulsing of nearby arteries by squeezing to get things started. And then the squeezing of skeletal muscles, which normally contract throughout the day, exert external pressure to keep the lymph flowing along, eventually reaching a nearby lymphatic trunk. To keep the lymph from sliding backwards, the lymphatic vessels have valves just like the veins do. The lymphatic trunks are each named after the regions of the body that they drain the lymph from. 2 lumbar trunks, 2 bronchomediastinal trunks, 2 subclavian trunks, and 2 jugular trunks, as well as 1 intestinal trunk. From there, the lymph is delivered to either the right lymphatic duct, which collects lymph from the right arm and the right side of the head and chest, or the thoracic duct, which is a lot bigger and collects lymph from the rest of the body. The right lymphatic duct dumps lymph into the junction of the right jugular vein and the right subclavian vein, and the thoracic duct dumps lymph into the same junction on the left side of the body. That particular spot is perfect because it's where the pressure is very low, which makes it easier for the lymph to flow in. The lymphatic system has key advantages. For example, it can pick up larger molecules, like hormones, that are too big to get into the capillaries, and then get them to the bloodstream. The lymphatic system can also help get nutrients to the tissues. For example, during a meal, fatty acids get packaged into balls of fat called chylomicrons by the small intestine. But just like the hormones, these are too big to move across capillaries. Instead, the chylomicrons go into special lymphatic vessels called lacteals, which get their name from the fact that the lymph that flows through them looks like milk. The chylomicrons slowly make their way up into the thoracic duct and get dumped into the venous blood. Now, the lymphatic system also plays a role in immune function. Lymphoid organs remove foreign material from the lymph to keep it from entering the bloodstream and act as lookout points for the body's immune defenses. Some lymphoid organs are in the form of diffuse lymphoid tissue, where they're just a loose arrangement of lymphoid cells and protein, typically in the lining of the gastrointestinal and respiratory tract. Another type of lymphoid organs are lymph nodes, which are tightly packed balls of lymphoid cells and protein. Hundreds of lymph nodes cluster along the lymph vessels, each one a few millimeters to about 1 to 2 centimeters in size. When they're concentrated along the lymph trunks, you can feel them, especially in the neck, armpit, and groin. They can also be found in the intestinal wall, where they're called Ayer's patches. When an infection gets into the tissue, it can slip into a lymphatic capillary and move into a lymphatic vessel. Unfiltered lymph fluid drains into a nearby lymph node, where any pathogen or piece of a pathogen is typically detected by a dendritic cell, which is a type of antigen-presenting cell that serves up pieces of anything it destroys to other immune cells. In the lymph nodes, dendritic cells continuously sample the lymph and present antigens that they come across to the B cells, which are a type of lymphocyte that can make antibodies. B cells are designed to only react to foreign antigens. And if the dendritic cell presents something foreign, the B cell turns into a plasma cell and starts cranking out antibodies, which then flow into the lymph and exit the lymph node. There are also circulating T cells, which are another type of lymphocyte that move between the lymph nodes, lymph, and blood, on the lookout for pathogens and infected or abnormal cells that have been tagged by antibodies. Another lymphoid organ is the spleen, which is about the size of a fist and sits on the left side of the body below the diaphragm and on top of the stomach. The spleen has both white pulp and red pulp. The white pulp is where antibody-coated bacteria are filtered out of the circulation and antibodies are generated by B cells. In a sense, the white pulp of the spleen is like a giant lymph node. Although unlike a lymph node which receives unfiltered lymphatic fluid, the spleen receives blood. The red pulp of the spleen is where old and defective blood cells are destroyed. And their parts, which are the hemoglobin, the heme chain, and the iron, are either broken down or recycled. The spleen is also helpful in that it keeps red blood cells and platelets available in case they're suddenly needed by the body. Really, it's an organ that's got your back in an emergency. Another lymphoid organ is the thymus, which is in the upper part of the chest, just below where a necklace might sit. The thymus is most active in the neonatal period and pre-adolescent years, and then slowly atrophies and gets replaced by fat after puberty. The thymus is involved in the development of T cells, making sure that any T cells that react to self-antigens, antigens that are normally found in the body, are promptly destroyed. The final set of lymphoid organs worth mentioning are the tonsils, which include the adenoid, tubal tonsils, palatine tonsils, and lingual tonsils. Together they form a ring of lymphoid tissue around the throat, and their main job is to trap pathogens from the food you eat and the air you inhale. All right, as a quick recap, the lymphatic system refers to the one-way network of lymphatic vessels that allows lymph, which is a clear fluid that streaks out of the blood, to transport nutrients to cells and act as a method of waste removal. This cleanse that lymph nodes throughout the lymphatic system, which plays an important role in immune function.
Okay, children, now what we have discussed in the video clip. Look at the first thing, the major parts of the lymphatic system. So the lymphatic system has lymph capillaries, which are among the spaces, or which are in the spaces among the cells, which are called the interstitial spaces. So these lymph capillaries are different from the normal blood capillaries that they have a dead end, and these lymph capillaries finally join together to make two lymphatic ducts, the right lymphatic duct and the thoracic duct. So these two open to the subclavian veins, which are coming from our hands, and finally release the fluid back to the blood circulatory system, so that the fluid which is circulated in the lymphatic system is called the lymph, right? Then in addition to that, we found the lymph nodes, and we found a special type of lymph capillaries inside the villi of the small intestine, which are called the lacteals. So all these parts together form the lymphatic system, and the lymph, the fluid is transported due to the muscle contraction and the actions of the arterial pulses. So always the lymph is transported to the direction of the heart, and then after it is returned to the blood circulatory system. So these are the things that we have studied from the video clips, and in addition to that, we discuss the functions of the lymphatic system. So just like the blood circulatory system, it transports the materials, especially the large molecules, the fatty acids like and hormones, and then in addition to that, it has a function of the protection the body from the infectious diseases by making the antigens that we have studied. Right, so these are the things that we have to study for the lymphatic system. And to finalize the blood circulatory system and the lymphatic system, then we need to discuss about the diseases associated with the system. For this time, we are discussing the diseases associated only with the blood circulatory system. So we know there are a large number of diseases related with the blood circulatory system, but in the syllabus, we have discussed only 4 diseases. All these 4 diseases are non-infectious types. Right now, we'll have a quick look at the textbook for a while for the diseases in the blood circulatory system, and then after we'll have a small discussion about the diseases, and we'll see the cases related with the blood circulatory system now. Right, so these are the diseases that we have discussed under the blood circulatory system. Then we need to discuss only 4 diseases. One disease is called the atherosclerosis. Other one is the heart attack. Then the other one is the hypertension. And the last one is the thrombosis. So if you consider this atherosclerosis, that happens due to the deposit of cholesterol basically inside the arteries. And when you hear the word cholesterol, at some occasion you may be you have heard about the deposit of cholesterol. Most of the time we think that cholesterol is it's a harmful substance to our body, but remember, it's an essential lipid that is produced by the liver, the thing that is not soluble in water, so that it is combined with the is combined with the proteins to make the lipoproteins. And there are two types of lipoproteins, that LDL and the HDL. So people are fear of this LDL, or the low density lipoproteins, which make the problems when they get deposits inside the artery, especially the space of the arteries are reduced, and as a result of that, that regions of the heart or the cardiac muscle will not receive the blood, and that condition is called the heart failure. So that the atherosclerosis make a condition in the heart which is called the angina, and that condition is also called the heart failure. So the main reason for having this is the consumption of food item containing the saturated fatty acids. So by doing the regular exercises and get rid of these saturated fatty acids, we can control the atherosclerosis condition. Then we need to study about the hypotension and the hypertension. So the hypertension is the high blood pressure condition. Hypotension is the low blood pressure condition. And most of us, we have the experience of the high blood pressure condition, which is the hypertension. So before we know about the hypertension and the hypertension, we should remember the normal blood pressure of an adult at rest. Now it is believed around 120 over 70 mercury millimeters, so that if the blood pressure readings change for a continuous period drastically, then that may be a symptom of these diseases. In the hypertension, the blood pressure increases than the normal value, but in the hypertension, there's a low blood pressure condition. So most of the people suffer from the hypertension due to number of reasons. One is the intake of the saturated fatty acids, as I told from the last discussion, even I told. So in addition to that, the mental stress is another reason, and the consumption of alcohol and smoking is another reason for the hypertension. So having our leisure periods efficiently, economically, and having a balanced diet with enough fibers, and stopping the smoking and the alcohol consumption, like we can control the hypertension conditions. For the hypertension, we have the medical treatments, and that's happened rarely among people due to the lack of nutrients in their diets. Right. Then the third disease that we need to study about the thrombosis. So that atherosclerosis and thrombosis, we some occasion confuse the symptoms and the cases. So I told the atherosclerosis happens due to the deposits of cholesterol, but thrombosis happens due to a formation of a blood clot inside the artery. So there are a number of reasons to have a blood clot. Normally we find the blood clots in an injury, which is the normal coagulation with the help of the fibrin or the fibrinogen plasma proteins. But this time, when the blood clot happens inside an artery, that normally blocks the blood supply to a certain body organ. So when it happens in the heart, which is called a heart attack, or the coronary thrombosis, because this happens in the coronary artery and it brings a severe pain. In some occasion, there may be some instantaneous death even due to this thrombosis condition. So that the number of reasons make the disease, but to get rid, we should have good health habits, just like avoiding the alcohol and smoking, and reduction the consumption of the saturated fatty acids, and then controlling our body weight, because obesity is one major reason for this most of the diseases in the blood system. And in addition to that, regular physical exercises, not doing one day and then stopping on another day, that we can control. And the other one is the controlling the mental stress. So then these are the diseases that we have to study for the blood circulatory system. So I repeat the 4 diseases. Atherosclerosis happens due to the deposit of cholesterol, which is that low density lipoprotein and it makes severe cases in the blood cell system and in the human body. And heart attack, we discussed that the condition of this thrombosis that happens due to the clotting of blood inside an artery. Then after we discuss about this hypertension and the hypertension. So that happens due to the changes in the regular blood pressure. So then there are two cases. High blood pressure is the hypertension. Low blood pressure is called the hypotension. So these are the things that we can follow to control most of the diseases related with the blood circulatory system. Now we have come to the end of the blood circulatory system and even the lymphatic system, then the heart, and we have only two more systems to discuss. They are the nervous system and the endocrine gland system. So we know for the efficient functioning of all these systems, there should be a coordination among all these systems. So in the human body, this coordination takes place in two ways: the nervous coordination and the chemical coordination. And chemical coordination is also called the non-nervous coordination. For the chemical coordination, we have the endocrine gland system or the hormone system. For the nervous coordination, we have the nervous system, which consists of brain, spinal cord, and the nerves. For the endocrine gland system, we have several endocrine glands that release hormones. So both these systems work together and they maintain the body coordination. So as a result of the coordination, the other body organs are given the relevant messages to work to the proper stimuli, and then only we can maintain the life processes in a specific manner. So today I thought to conduct the lessons to give you the knowledge on the lymphatic system and especially the diseases related with the blood circulatory system, so that next day onwards we can continue the lesson for the body coordination. So body coordination part is the last part, and then after we have only one topic to discuss, that is the homeostasis of the body, to finalize this lesson. So that now so far we have discussed a lot of systems in the lesson except the nervous system and the endocrine system, and we have discussed about the digestive system and the digestive processes. We have discussed about the respiration, the respiratory system, and we have discussed about the excretory system, the excretion and the urine formation, and then after you have discussed about the blood circulatory system, which is longer than the other system, the heart, blood vessels and the blood, then two components of blood, and then the arterial system, the double circulation, like concepts, and then after only we came to the lymphatic system discussion, where we discuss it consists of several parts, and the lymph capillaries join together to make two major lymphatic ducts, and they release their fluid, the lymph, back to the blood system, as I showed you by the video clips, and they circulate this lymph and transport the materials and protects the body from the diseases, right? So these are the things that we have discussed today, and then last day we talked about the diseases, and we have to study 4 diseases. Then we have finished the discussions on them. So next day we will continue the lesson for the coordination part, and till that we will finish, and good night for you. Thank you.